right back. The first thing is the drills. But yeah, sorry for the bit of trouble, but I'll be right back. Okay, I'm back. So I just have to I have to today. Let me open up Obsidian first. Um, and I hope the thumbnail is good. Okay. Today. Okay. so I just have um so basically we're gonna be doing the drills. Then we're gonna go into um we're going to tear, open in tuple. Then um we're gonna do some work on this file that we were working on. You know, check stuff. Map, and then we're gonna do something. I found this. Um, I found a website which is so the website is called and yeah, what we're gonna be doing get cracked.io thing, and this is basically by a YouTuber. I'm also speaking kind of quiet right now, but um, yeah. But yeah, ugh. as I was saying, never mind. Yeah, that's what I mean. But yeah, I'm going to I'm going to do the SSH again, and then I'm going and then bit of this do and then do a crack me or a couple. Then yeah, this is basically it. Or then we can do a couple. So, see what we're doing today. This is the goals. Yeah. Okay. Let's get started. What was the first thing? Yeah. Shouldn't have closed it. Goals. Doing the drills. Okay. So let me just folder two. Let's go and to open because fresh. Okay. So now we should be able to move. What should we call it? Yes, a underscore yes, and then from home says copy from desktop says it's gonna show up after we do that. Um, command copy from sub ssh local host p delete. Okay, I'm in. I can do cd files. I can do push it to asm and paste. Okay, Control X, save here. Now I can log out. Should be there now. Slash file slash date to the asm to the asm. Okay, yeah. Just make sure. Yep, it doesn't exist. Here. We can open this in mousepad and then open a terminal here. Yeah, vim C Okay, so the server the void v2 underscore one, and then here, so you can see it pushes subs at sub 16 sub RSP, so that so we know that it's gonna allocate 16 bytes of sub. It moves D word moves 15 into what equals 15 underscore 8 equals um, 8 equals 3, and then what's it doing? It's doing um, hmm, moves. Okay, so it multiplies EAX and EX. Stores that in EAX. And I'm pretty sure the result of the result always goes and it extends up to EDX. Depends on the okay. Okay. And then destination. Okay. So, so and PM is equal to orbit and then this returns that's simple. It should be an integer return. This is a keyword. 2 underscore 2. So it's subs 16 again. And then BPM score the D word again. So and then it moves into EX thing. And CDQ this I think it just extends the sign of EX to into EDX. CDQ. Convert double okay. Sign that extends to 32. Copies the sign bit of EX into position. Oh, okay. Okay, okay. It's just gonna like copy the sign into it. Okay. Copy the sign while extending the value. CDQ. Did you just say CDQ? Extends then it does idiv idiv d idiv rbp underscore equals this edx divided by 8. What is edx? Edx is equal to ebk is equal to 4. Okay, rdx rdx I'll be sure into shoot. Actually not keep it. And then it just set that into rbp underscore 12 is equal to rbp underscore 4 times rbp underscore 4 divided by rbp underscore 8. And the remainder is in edx. Okay. Okay, wait, that's good, but let's move ex into there. And then it scored 12, 16 is equal to, for the remainder, right? So it would be, um, how do you get the remainder? I'll just do that. Okay, so, and the remainder can be calculated, I think, like this. So this, how much, is RBP underscore 12, like, that would be like, so 100 divided by 7, of course, 100 can't be divided by 7, but 7 goes up to, um, let's see, 12 times 84, 13, 91, okay, and then 7 times 14, 98, okay. So that result would probably return 100 divided by 7. Yeah, it would return 14 for that result. And so to get the remainder, you just have to multiply RBP underscore 8 times RBP underscore 12 and subtract square 4 minus 6. But this isn't actually what it does. It's like the division is like not like this. It calculated. That's too slow. It just has its own like algorithms that are quick. Uh, it just moves the. It only return, and so we know that. So again, that's again a keyword, so it's an int. And then this one. This one seems a bit complicated. Yeah, wait, what is it doing? It subtracts RSP by 32. So it reserves 32 bytes of space. So RSP 32. And then sort 4 equals int RBP squared 8 multiplies EAX by EDX. So, okay. And then source that in int, source that in int RBP underscore 16 RBP underscore 4 underscore 8. Be these two. 8 times 2 is 16. And then it moves into um and then it stores into RBP underscore 20 right here. Stores EAX, which is the result of this operation. So right here, it's going to be puts in the Scott into EDX RBP underscore 12, and then yeah, it just adds those equals R equals RBP underscore 12 plus RBP underscore 60. The way that I'm using is okay. So as I was saying, RBP underscore 20 is that, and then it adds that into RBP underscore 20, and then it moves into EAX return RBP underscore 20. Okay, that's it. These are pretty quick. I mean, I guess I'm taking like too long. I'll try to do the next one as fast as I can, like rapid mode. Okay, so it's void e2 underscore 4 does sub RSP underscore 32, sub RSP by 32, and then moves into int p underscore 4 equals 15, RBP underscore 8 equals 15, RBP underscore 10, and then subtracts RBP underscore 4 by RBP underscore 8. In new variable 16, and then it's what's it do? Int RBP underscore 20 moves comes into it 16 underscore 16 by RBP underscore 12, and then return RBP underscore. This is really simple. These are really simple. 16 times 2 is 32. That makes sense. WQ. That's day 3 done. Day 3 of drills is done, and now we're going to do this. We're going to have this binary from day 1, and let's run it real quick. Oops, that's the wrong file. Delete this. Day 1. It's going to copy this. Go to day 2. Paste it here. Clear. Clear. Crack. CD. LS. Okay. We're just going to do this. Oops. Accidentally leaked my password. But this doesn't matter because we're going to be doing some cool, crazy stuff in here. So we're going to be, that's where the thumbnail of this video is coming from. We're gonna be, well, we have to check what type of file this is first. See? Okay, so this is the F file. This is where it comes from. This is where the thumbnail comes from. Dynamically ranked interpreter is this. And build ID, that doesn't matter. This is some stuff. And for this, strip. Okay. It has debugging symbols on. But basically now we can do this. Let me get my flowchart ready. So after we run file, we're going to read elf. Okay, read elf. Let's see this function, read elf. Okay, all, and then dash h is this gets the file header, program headers, and alias for program headers. Okay, section headers. This is what we need to see. Um, okay, so where's it? What is a GOT? GOT section. What is GOT contents? GOT display the GOT section contents. Okay. Okay, so let's try one of these commands at once. Is there a way I can just like copy? Let's open a mousepad. I don't like having stuff on my terminal. Yeah, how do you run it? I forgot how to like how to run but it is try no help. It's not gonna do that. So mouse pad. If I do that, mouse pad. Yes. Okay. Um, paste all of that here. Let's see. Okay. So read elf dash h. Okay. Gives me this magic number. Class data. That's how it's stored. Okay. ABI type version machine version entry point start. Okay, this is useful. Start of program headers 64 bytes into the file section is this into the files. Okay, so what is this? L. Okay, dash L program headers. Let's see what's in here. Okay, files dynamic DYN, not dynamic. G pointers 14 headers. Okay, and offset 60, 64. 40 is 16 times 4, 64 bytes. Okay, first thing is this. What is this? We have to research all of this because we are the best researchers. Yes, we are. PSDR, Linux, PSDR. What is PSDR? Program header. Okay. Size, segment. Is there a virtual address? Huh. I mean, it's not really like, okay. Virtual address. Wait, how does this like, how does this work? Okay, so PHDR is at this address. Just, I guess this is just like saying this is the start of the letters. Read, write, write. Okay. There are R and E. Okay. Requesting program interpreter. What does this mean? Yeah, let's look at my flow chart for this. What are we supposed to like gain from doing this? Okay, load segments. We're looking for an inter. Is there something called TLS? There's no TLS. Right? Yeah, there's no. Okay. So okay, let's just look at a website that might give me like elf program. Program header struct p underscore align. Okay, align alignment. Okay, flags is either read or something like that, and align is this. This is the offset at first, and then it gives me the size of the file. So up to 310, and 310 plus 0x40. Should that end at here? Or is it just giving me like padding? Padding shouldn't be required because this is alignment is 1 byte. So well, this one's alignment is 8 bytes, so I guess it kind of makes sense. So it starts at 310. It starts at 40. Add 0x 40 plus 310 350. Okay, 350. How much? What is the difference? 3b4 minus 350. 64 bytes of difference. So there's 64 bytes of difference between those two files for some reason. What is contained like within those? And then there's this, and the size is a decent amount. And then load has an offset of 0. And it spans this much, then it would have to override those. So how is the load offset here? Okay, physical address of 0. And then it spans this much. Okay, let's look at this. Maybe this is gonna give us a program header. Load, okay. Unused. Name was contain. Ignored. Ignored entries, okay. Specifies a loadable segment. Map to the specifies a loadable segment. Alignment is 1,000, so it does make sense that the next one starts at this much. Or this is 1 page of alignment. That makes sense because that's like a multiple of 64. Okay. Specifies a loadable segment. What is it? What's a load segment? This is what we're doing right now. Okay. Mm, Okay, okay, wait. So this is like these are like code and stuff like that for the thing. These are the codes and stuff. Okay. Part one, sections and segments. Okay. Linking. So is this? Am I looking at the sections right now? No, I'm looking at the program headers. So I'm looking at the segments, not the sections. Go down segments. Sorry for not reading this out loud because there's like people right now. So every ELF contains a program header table. There are different types assigned. Yeah, so this is the unassigned thing. It's useless. PT underscore TLS. Okay, but there's no. Is there any TLS? Coding dot dynamic section. This is the same thing we have. Get loaded into memory. If every other segment besides PT load is mapped within the memory range of one of the. Okay, of one of the. Okay. So like these are the only things that get loaded into memory, and all of these are gonna get mapped into one of these. Okay, this is the offset. This is not the starting point. And well, and these won't be these have a physical address, right? Yeah, these two have a physical address, but and this one does as well, but this one is gonna be in the RAM, while these ones are on the disk. Okay. Dynamic GOT data BSS. Okay, so in the memory, this is gonna load PT load 0, 1. Okay, and there's alignment padding between them, like how we can see the padding here. From it jumps from 1688 to 2000, which should be the next padded thing. Okay, so let's see which ones are important. Elf header is okay, I guess, and PHDR. Well, I all of these are important. So our data in the code is there. Read only in the code. The data in the BSS. The dynamic.god. Okay, we have to look at sections. Initialize POT. POT is inside of one of these. And symbol table, interp. What is that dot? Dot. I, this one seems interesting. Not it. Interp. Linux. First section identifies required to run the program. So is this literally the dot interp? Contains single section. Okay. Yeah, so right here. Mm. What does the linker do? What does the linker? Yeah, ones. Okay. Read read in symbols. Okay. Read in section and unresolved references. Update address and write out the executable file. Link in memory. Compute memory layout. Section sizes. Read in. Symbols. Dynamic linking. Yeah, so this is just the GOT stuff. Okay. We basically kind of know. Okay. Let's look at the S. Look at sections. And where's the mouse pad? Yeah. Okay. Yeah, that's a lot. Okay. Yeah. Dash S. Oh, okay. That's not. This is the symbols table, not the. Okay. So okay. I don't know what this is. I don't know what this is. And then this is a section. This is the address. 3v4, 3v4. And it says the size is 1C, which makes sense because it's small string. GNU hash. These are some GNU stuff here. And dynamic symbols. Okay. .pot. .pot here, and then the text begins here. And this is the size. borrow data frame, dynamic GOT is at the end. And no, it's not. And then the BSS data, stuff like that. Okay, that's all. I have to let me see what the um dynamic section and the EH frame is. Dynamic section. Section. Wait, what did I say I was gonna do? Okay, we're gonna finish this, I guess. EH frame containing for unwinding. Okay, this is code then. Codes for runtime linker. So this is also very useful for GOT then. This is how GOT gets this stuff. This dot dynamic section essential to GOT and GOT and GOT. Yes, is essential. So the roadmaps providing to locate and populate runtime. Okay. Just the linker running links. LD.so. Wow. Program. Wow, that's a massive CPU spike. What's this from? Oh, it doesn't like I can't really see it. Agent applet.py remains mapped and can be called throughout the entire execution. Lazy binding external first call. Back to the dynamic linker defined address. Okay. To open close. Okay, we should well we're gonna find what all this means when we okay. Read alpha dash D. Okay, now we can see the dynamic library is needed. This one is needed. Um, libc is needed. Okay. Let's see what does init mean. Init means stuff that runs before main. Okay. Init underscore array is the same thing. Fini is stuff that runs during teardown. Okay, so the is this in is this these two are in the same like the same load segment. Yeah. Because I saw that this one begins at a new load segment and this one too. And init array is I guess that's a data thing. Infinite array is also because they store pointers. Okay, yeah. This one stores the pointer to an actual array. This one too, okay. And GNU hash. Okay, let's see. That one probably doesn't matter. It's a GNU thing. But D, let's see. Um, DTR path. Where's DTR path? It doesn't show it here. Okay, I guess it's fine. Okay. Read elf SW. Read elf. What is it? Let me see. What does this give me? This shows imported functions, exported symbols, dynamic symbols. Okay. This functions, I guess. Unwind resume. No, don't open. Out. Start. BSS start. Okay. Okay, read out dash R. Read elf dash R. This relocation. Offset this type. Okay. What does this mean? Okay. And then copy. COUT. Okay. Mm. Shoot. Okay. I can get info from that, and now it's the object dump. Object dump. archive file headers, private headers, section headers, disassemble, okay, that's D, disassemble all, I guess, dash D, dash D, okay, object dash D, that's a lot, okay, note, GNU property, not what I want, this is from the stuff, this is supposed to be a string. If you like get all of these, I bet that would like turn into a string. It ends in a 0 0 as well. 2F. Okay, it's a string. 2F. What's that? Slash 60. That doesn't mean anything. But 32. 2E. Okay, I guess not going to work. But I know that this is a string, not an actual thing. GNU hash, this is also probably a string. Because these commands don't make sense. Right? Or do they? Yeah, what is this? And wait, how can I? Is there no way to change the syntax? Um, there should be like a way, right, to change syntax. Object, object dump, change syntax. Dash M. Okay. Object dump. Dash M. Until. Okay. Not comment is a section. Okay. GOT. We should look at the GOT. Is there the text section? Okay. Init array. ABI. Okay. These are actual functions. RDA RX create error message. Close this thing. RP. This has to be like a global offset, right? GOT thing, because it's using RP as the IO CDN used. So that's probably like a GOT data, and it throws that and moves into RX RBP minus 20, which is stack. Well, it's a pointer. Moves the pointer inside of here, and then that pointer points to some other pointer, and dereference that, get it, and then compare it. Jump above or equal to. So if this is equal to or above RAX, so that might be like a key or something. Get allocator, move RX, move RPX, R12. It's saving RX. Why would it do that? Okay. I understand it's saving these two because these are colleague saved. And it moves into RDX. So it doesn't take any arguments. If it did, then RDX would have the first file. Okay, so it moves into RDX, whatever R12 was, which is a okay. And then after that, right after that, right before that, before this pointer is RCX, okay, RDX and RCX, and then moves into RAX this value. And then call, and then pop. Oh, what does it send from RAX? It sends this pointer. But RAX already had that pointer in there. And now it's giving it back to RAX. And then it sets a second param for as RCX. And then first param is this. So this and this one is important. Meaning what RAX contained. And this one, what RAX and R12 contain are important. But it's not using RBX. Okay. Maybe this is like a stub, like a continuation of a different function. Or well, I guess it starts from here. Let's see what this one does. Basic string m destroy m. Okay. Oh, okay, that's why I deallocated. And right here is deallocating. And okay, so it pushes those two. Makes sense. subtracts 30. Okay. And allocates 30 bytes of space, or hex 30 bytes of space, which would be 12 times, 60 times 3 is 48 bytes of space. And then it proceeds to, it moves RBP into RSP, right? And then it pushes R12 and pushes RBX, which will um put our speed to 0x. Well, it would offset RSP by um how much is it? 16 bytes. So 16, and then minus 48, so 64 bytes, which is 40. Okay, 64 is right here. This is the last variable on the stack without exceeding. Okay, it moves a keyword pointer here. Moves the keyword pointer here of RDI, right? And then it immediately moves RSI in here. Well, these will be the arguments, right? And why is it just overriding it then? Oh wait, because sorry, I thought 38 was like actually 38 and 40, but this is the hex, so this is 8 bytes after. Okay, so saves the first argument into a variable, and then saves second argument into the variable as well, and then moves it into RX. Okay, the a field, or no, not a field. It's just, wait, it could be a field because it's moving RDI into here, right? So RDI, whatever RDI contained, which is probably a pointer, into IX plus 1 from that pointer into R12, and it pushed R12, so I can use R12. It's moving into RX the second, the first one, right? And then it's okay. Let's actually do this and see. Um, I actually like just assembling like a lot. Vim cd desktop ls. Let's copy this function. Cd 290 days ls clear cd day 2 cd yeah, and then I'm just going to vim rewriting functions. C. Okay. Okay, so first just include stdio because maybe I want to run this, right? Who knows what might happen. Okay. Well, let's call this, let's make this function base. Is that like a valid function name? I mean, If it starts with that, then it should be right. But it has this thing here. So and then you have a is it well we're not sure what it returns, so let's just go with the flow. And we know that it's taking in two arcs RDI and RC. Okay, let's see what it's doing. It's moving into let's see, creates push 30, push R12 RBX, and then it sub RSP 30 0x30. So RSP should be 0x30 minus oh no minus 0x30 minus 0x2 oh minus 8 times 2, so minus 0x10 bytes less. So RSP is at 0x40 or 64 bytes from from before called. Okay. Okay, so we can do this. Let's separate this because it's important. Actually, no, let's put it back. Okay. What do we know? Well, we know that it's moving a keyword, so long RBP underscore 38 equals RDI long RBP underscore. We can actually like probably even like emulate this function. That'd be nice. Long RDI, comma long long. Sorry, is there a tab there? Messed something up. Let's fix it. Long. And I know I said we're gonna like strip the binary, but like this is fun. Okay, RBP underscore 40 is equal to R star. And it sets RX to that and then loads into R12 that bit field. So we can just set it move into RX RBP underscore 38 load and set R12 to RAX plus plus 0 0 1 0 0 0 1. Okay. So we know that our RBP underscore 38 contains something, and that something contains fields. So RBP underscore 38 contains a pointer. That pointer contains fields. Pointer, that thing, contains a structure. Okay, so R12 is being loaded with this. And then we can say that RDI is being called RX. Okay, move into RDI the value of RX. So just call this random thing. Call paste is going to be called with RBP RBP underscore 38. So first do that, right? Whatever it contains, we take it in, and then we plus 0x1 with it. Okay. Oh wait, no, that's not it. We actually move into RDI the value of this RAX, which is 38. So RBP underscore 38. And then we move into RBX, the result of RAX. And okay, so the result is saved from there. Okay, so then we call, so right here it assigns it here. So RBX will contain, okay, so this is an int, but we don't know if it's an int. Yeah, it's a long b underscore 20 equals that, right? And then we move into RAX. Is are these the same functions? No, these are different functions. Okay. Get allocator. So we get allocator for that, I guess. And where is that being stored? Into Xerox 28. Oh no. RBP underscore 28 equals this call. What do we call it with RDI is equal to just RX, same thing. I'm getting worried about this, bro. I want to save this somewhere. Okay, save there. Um, RBP underscore 38. And then it's going to save R12 into there, and we know that R12 contains this thing. Okay, and then so right here we can do long RBP underscore, what is it, 18 plus, and these are all 8 bytes away, by the way, keep that in mind. So 28 is, Oh well, we haven't used 30 yet. We should be used, I think. 0x30 is never getting used. Okay, that's a bit weird because it uses these. I guess it just wants to make space between the arguments that were provided and the variables it's going to initialize. Okay. Underscore 18 is equal to R12. And it seems to be like doing stuff in reverse order because it's first initializing these values and then this. Okay. RBP underscore 18 is why did I do that? R12. Here we can say that. No, actually this is this. What was it again? It's move into RX38 to dereference 38 plus 1 here. RBP underscore 38 versus R12. Okay. Well, actually, we don't need to dereference it because moving is just we're just we're just saying this is the dereference thing. So yeah, it didn't dereference anything. It's just moving whatever is in here. So yeah, we're just using this as a container, and it loads that into here, so that we can actually see that this is a pointer, and it loads this field, and it passes this in. This seems to be important structure. This seems to be the string because it also used RDI, which is always a this, and then it puts the RSI. But we never actually used RSI yet, so see. Let's see what RBP underscore 40 is used for. Or maybe, wait. Okay, since RSI is always the second argument, it's true that it doesn't need to do anything as long as it just like keeps it there. Yeah, so RSI is always on here too. Okay. So it needs both of these things. And then it loads into RDX, RCX. It loads into RSI, the value of that. Okay, so RDX is getting used 18. I'm assuming this is like a Boolean flag. So, well, unless it's not, I mean, it's just loading in this random thing. Okay, whatever. We'll worry about that later. So it passes into this function, these three stuff. Oops. Paste. Passes in RBP underscore 18. First param is RDI, which is RX, which is RBP underscore 28. 28 result of this call. And then what else? RSI is equal to RCX, which is RBP underscore 20, which is RBX, which is this result of this. Okay. RBP underscore 20, which is the result of this. What's this do? Data EV. Okay. Um and then RDX, which is RBP underscore 18. Score 18. Unless it's passing in RSI in here, then I would be like confused. But I'm just gonna like give this code and give this to Gemini and see how it does things. Oh wait, I forgot. This is this is all okay. Pop RPX. Oh, does it return anything? Call this function. It just depends on whether this function returns anything. Copy. Let's give this to Gemini. Does this look mostly correct? Analysis and then check. There are a few nuances. Okay. R12 is coming from. Oh yeah, some. Is it from something else? Oh yeah, it's from 40 instead. Okay. Okay, so that matters. So RBP underscore 40 is a data. It's the actual thing. Or what? Underscore 48. So, so it's about actually, and no, inferring what data. Okay, it doesn't set pointer to null. Doesn't matter if it does because I mean unless well they could I guess they could cause like a use after free. Okay. Mm. But okay, I guess. I mean I'll just need to like look at like so many more of these type of things to get the hang of it. Yeah. And this one was also wrong. It should be RBP. Wait, no, this is fine. Okay. Oh well, let's just continue from where we were at. Did we not like we use obj dump and stuff? Oh yeah. cd obj dump hd clear. Okay, well I guess it's just gonna show me like the different stuff. Okay. So now I'm just going to like do this. Okay, so okay. Um I can do file read of read of read of um that's h. Okay. We need the ng point. Ng point is right here. Copy thing. Okay, now I can do a GDB on this file track get a set as deliver tell clear yes help break data. Okay, break I okay. I can do XSW PC and I PC. Okay, so I is instructions and yeah. Okay, so let's do 100 I. Okay, Q C to continue. Okay, we have a big blob. Where's the ret? Is the rets? Okay, so let's just look at this function. Is ret right? Where is it? Oh wait, it can start here and then move. Nope, red right here. Okay, so until this point. Okay, and what is this? What is this function? Okay, if I do this symbol paste this symbol address in, what is it in GDB? Okay, this 7FE by 1F0 plus 30. Okay, finally we have some stuff. Continue. Okay. Push. This is a GOT thing. I think no calls here. EF. This is a comma. Okay. How do you typically like find something from that tree? Hmm. Do you typically find the main DB if start at entry first instruction? D squared. Is this what it's about? Info. Info files. Here's the entry. Okay. Here's the entry. I see read L S H. Right now. Tree is that right here. Okay. Let's see. This 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 point plus 20. Is it because it has to be here? Okay, so this last 4 bytes. Okay, so 1, 2, 1, 2, 3, 4. Okay, 1, 2, 3, 4, 7 F F F F 7 F D. Okay, 1. Oops. 0. What if I add like a number here? Oh, is it because I'm like putting in the wrong thing? 0, 0, 0, 0, 7, 1, 2, 3, 4, 7 F 0, and then 2, 0 F 0. This is, oh fuck, 7 F. Yep, that's good. F 3, 4, 5, 6, 7, 8. C D E. There's a random chance we're gonna do it. What if it's all F's? Okay. Hmm. Okay. That's offset. For start check point, but I don't know how to find where it loads program. Since you know you need a base address, info prop mappings. Yeah, RX. Alright, so this one is definitely me. And the heap isn't even set up yet, so okay. Or something like that. I don't know. Actually, so X will be here. Paste, copy, or start here. Copy, plus, cut. Okay, so what's the command again? Info prop mappings. Okay, let's paste. How many is this? 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. What the? This ASSM. This assemble. Okay. continue. Info about Wait, this is actually where it is. So this one was bad. Okay. 50. It's because the thing hasn't loaded yet. Okay. What? How's it skipping this? Break underscore init. Okay. Wait. Wait, so is the first thing that's ever going to run. This ASM. This one. Okay, never mind. Okay, let's inspect what the value is. Still 0. So it's not going to jump here. I mean, it will jump here. Okay. 16. So it's not going to call racks because that would crash the program. And then returns to where. — 6050. Okay. Lipsy start main. It's comparing a bunch of stuff. Okay, this is Ron. No. Irvin. Yes. No. Oh, this is on nine. How do I do it? Do I have to put this thing? I know that this is probably this is yeah, this is the address. Paste BR. BR. Okay. How do I fix that? BR. UDP. UDP delete. Delete. BR. Right. Okay, so this it needs to be doing that. Okay. BR. Okay. Bar. Okay, so now we finally have the thing. So access, access, and IPC. Okay. 100 IPC. Continue. Oh wow, there's the main right here. Okay. That reveals too much information. Um Honestly guys, I might just take a break. I've been streaming for so long. I'm gonna hit the gym or something. Um 10 6150. Yeah, it is 50. Should we really like okay. Well start isn't that big. We could technically like Trying to see the instruction that jumps from the linker to my program. Okay, yeah, guys, I think I'm just gonna go like take a break. It's like save the state. Yeah, see you guys. Okay, then, yeah, see you guys. I'm just gonna go take a break.